Good morning, good afternoon, and wherever you are around the world, a huge welcome to today's Postgrad Insights session, which is brought to you today by UCL Engineering. They're going to be talking to you about all things engineering, as you can expect, and what it's like to study and to live in London, which is where UCL is based. I'll just give everyone a second to join before I hand you over to Lucy and to Max and Catherine, who are going to be taking you through today's session. If anyone does have questions, concerns, or issues, place it in the chat facility. If you have any questions, there will be a Q&A facility at the end of the session, which will be moderated by myself. So please feel free to put it in there. And likewise, any questions or any concerns, please email gareth@postgraduations.com. It is a live session, so if you are watching on the socials today, if you are watching in the future, please email myself again or email directly to Lucy or to whoever's in the presentation who might share their information. So I'd like to hand you over now to Lucy. Lucy's the marketing expert at UCL and she'll be taking you through the next 30 to 40 minutes. Lucy, over to you.
Hi, everybody, and welcome to today's event. I'm Lucy Thompson, and as Gareth mentioned, I work in the marketing team at the UCL Faculty of Engineering Sciences. So today's presentation is going to be an introduction of sustainable engineering as a theme that spans our educational and research practices here at UCL Engineering, rather than introducing you to individual MSc programs, although we'd be delighted to be in contact about those after this event via email if you're keen to hear more. You'll then have the opportunity after my presentation to hear from two academic colleagues on the call who will present the way in which sustainability is embedded within their research and teaching, and to give you an idea of what we do here at UCL that makes us a really special place to study. So I'll start today with an introduction to UCL Engineering. Firstly, welcome virtually to UCL. When you consider joining our university, you're taking a step to be part of more than simply a place to study. Our world-renowned institution has been challenging conventions since its founding in 1826, and today our research and graduates continue to impact, inspire, and move the world forward. As you can see from our list of disciplines here, our academic expertise spans a broad range of subject options, all contributing to the success. As you can see here, we are the Times and Sunday Times Good University Guide of the year 2024, and UCL is ranked 9th in the 2024 QS World University Rankings, 2nd in the UK for research power in the Research Excellence Framework, and there have been 30 Nobel Prize laureates among UCL's alumni and current and former staff to date. Just to add to this, UCL secured 10 subjects in the top 10 in the world in the QS rankings by subject 2024 just last week. Our faculty and its 10 departments listed here are proud to contribute to these aforementioned achievements and more. At the Faculty of Engineering, you'll find home in your department while rubbing shoulders with students, researchers and experts from a whole host of specialties across engineering. Our faculty includes, as you can see, some of the more traditional engineering areas, such as mechanical and chemical engineering. In fact, we're very proud of that history. We are the first mechanical engineering department in the world established at UCL, and we were the first to introduce laboratories in engineering education. We also encompass some other areas you might not expect to see in the usual suspects of engineering: computer science, the School of Management, security and crime science, and science, technology, engineering and public policy. This makes UCL Engineering particularly special since it creates the opportunity to experience engineering as an interdisciplinary and multidisciplinary field. We think that good engineering happens when people with complementary skills work together to solve problems. So our setup aligns to changing 21st century engineering and industry requirements for innovative, curious graduates who are not only technically brilliant in their chosen discipline, but also have a broad knowledge base and are used to working with engineers from other areas as well as non-engineers, and can effectively communicate and promote their ideas. Our students receive world-class study and research provision. In the state-of-the-art facilities in both Bloomsbury and our new UCL East campus at the former Queen Elizabeth Olympic Park, which was home to the 2012 London Olympics. What's more, you'll find your programme is complemented by unbeatable industry connections, which provide invaluable experience, development and career prospects for students of engineering. You'll benefit from access to corporations revered all over the world, and our collaborative partners and industry connectors include these listed here, but are certainly not limited to these, including DeepMind, Mercedes, IBM, Facebook, and the like. You can find out more using the link below. So from UCL engineers turn discoveries into solutions, from medical treatments right through to houses and transportation. Our research helps to change the world we experience. You can use the QR code here to access our Disruptive Thinkers video series to hear more about our research. Our sustainable engineering portfolio features research on how waste can help us to get to net zero and how we can transform businesses sustainably. UCL is a very special place if you have an interest in sustainable engineering, and that's in part due to the size and scale of our institution. We're home to many departments and faculties with a stake in the sustainability game, spanning architecture and design, education, social sciences, and of course, engineering. Mechanical, chemical, electronic and electrical, biomedical engineers, even business and responsible finance experts come together at UCL Engineering to progress research in sustainability. From earthquake resilient buildings to plastic eating bacteria to carbon absorbing biocurtains, our researchers are leading the way in global sustainability. These examples also show that at UCL, we are committed to academic research that can be applied to the real world to drive innovation and impact. Our work with industry and external partners worldwide allows us to apply what we do to the life sciences, healthcare, manufacturing, energy, transportation sectors, and many more. We also have a number of programs that focus on sustainable engineering specifically, but we're more proud of the way in which sustainability is woven into all our programs and our ethos. In metrics from 2022-23, UCL achieved a 53% carbon reduction from building energy use compared to 4 years previously. There were 188 sustainability-related modules and 115 climate-related modules at UCL. And there were 2,160 modules that relate to one or more of the Sustainable Development Goals set by the UN. And this is growing all of the time. Of our 104 postgraduate programs at UCL, this list features some of those which are particularly aligned to sustainable practices. However, for those of you attending with an interest in programs not featured here, I'd encourage you to check the prospectus pages on our website for module details that will confirm opportunities for specialism in this area. We're also pleased to announce the launch of several new programs coming soon, including the MSc Structural Sustainable Engineering that will be led by Dr. Catherine Cashel, who will speak today, and several business programs with a focus on social change and sustainable innovation. A quick slide on applications to answer some of the questions we anticipate from you today. For those of you considering applying this year to start your MSc programme in September 2024, applications are still open for most of our PGT programmes with the following deadlines. So until the 28th of June if you require a visa, and until the 31st of August for UK applicants who do not require a visa. For those of you considering applying next year to start in September 2025, applications will open in mid-October of this year. We'll also be running a series of open days on specific programmes in autumn and winter of this year, where you'll have a chance to chat with academics, programme directors, students and the career service, and to get in-person and virtual tours of our facilities before you apply. I'd also encourage you to visit the page entitled Applying for Graduate Taught Study at UCL. Just type that into your URL search bar to find out more about the process, dates, fees, funding and application support for UK and international students. If you're looking for further information on funding your studies, the university website also has a comprehensive list of options from full scholarships to small awards and bursaries. If you know which programme you want to study, I'd also recommend you look at departmental websites for information on scholarships and bursaries specific to each department and in some case to each programme. You'll also find the details about prizes that current students can obtain during their studies. Don't be concerned. While some of these have now closed, most scholarships are still open for application until May and June, and there are these small prizes that current students can obtain during the course of their C programme. And this is where my introduction ends. I'm delighted to hand over now to Max Basenhart for his presentation that spotlights advanced materials. Max is a lecturer in digital manufacturing of advanced materials and also the programme lead of that programme in the Department of Chemical Engineering.
Big welcome. My pleasure to talk to you a bit today about chemical engineering. Why is chemical engineering so important to achieve sustainability, and also as the program director of our new MSc program in digital manufacturing of advanced materials, I'm going to present a few more details on that program specifically. So I mentioned before chemical engineering and how chemical engineers are so important for our sustainability goals in the world. For those of you who do not know what chemical engineering is, I think it's very fair to say, well, it's needed everywhere. We need it for things like transportation, energy, battery materials, healthcare, food, all these main things. We want transport, we want medication, we want nutrition, and chemical engineers are very much embedded in the supply chain of all of them. How important that is, we might have still in mind from the pandemic when a drug was discovered, but just from the discovery to the production, that this is actually a big bottleneck, how this all slowed us down and how long it took, or how fast and then it was possible to outroll the vaccine. That was very much due to the availability of chemical engineers working very hard in that field. Also, if you want to know, well, where do we find chemical engineers? Just have a look what the biggest companies are. I guess Apple, Microsoft, we all know them. I assume we're sitting in front of one of their products right now. But if you watch the other big companies after this, is all energy related, healthcare related, electronics related, transport related, nutrition. And as you can see, this is where you find chemical engineers. So in simple terms, electronics, products, consumer products, transportation, very much pharmaceuticals, energy and food. And obviously, this is very much dominating our CO2 footprint in the world. So we need to do better in all of these disciplines. And that's why we need to push the limits of chemical engineering. Luke, you mentioned it a bit at the beginning. How old do you think we are? Well, we are indeed the oldest chemical engineering department in the country. And we are celebrating our centenary this year, which means we are 100 years and more old. And if you want to learn more about the rich history of the chemical engineering department at UCL, have a look at our website where we find a bit of videos and additional material on the history, what happened 100 years ago, and how we're going to teach now. A few more key facts on the department. It's a very big department, and at UCL, chemical engineering and biochemical engineering are not merged into one department. So there is a very separate department on chemical engineering. We have around 430 undergraduates. We have like 100 to 200 postgraduates. So this would be MSc students. Of course, research staff, PhD students as well, and just below 50 of academic staffs. Of those, 22 are teaching. So as you can see, a rather big department. And within this big department, we host 5 different MSc courses. The courses I'm quickly describing to you now. It's if you want the core, they're very classic chemical engineering, which is, of course, in demand everywhere. It's the chemical process engineering MSc. We have combined a bit more with management, the MSc on global management of natural resources. So these were, if you want, the 2 more classic MScs enrolled in our department. And new to the party with a new campus, I'm going to show you some slides later, is the MSc in advanced propulsion. This is where our colleagues speak about clean economy. It's very much about battery materials, fuel cells, e-cars, and general green ways of transportation. And we have the digital manufacturing of advanced materials. I'm going to explain in details below. This is the one I'm program director of. And last but not least, we have the nature-inspired solution, which is an MSc designed where we can learn how nature is solving problems and learning from nature to embed this into modern day chemical engineering. Where we are, well, you might know that UCL, I have to say the Bloomsbury campus is very much at the heart of London. But as I've said before, the way chemical engineering has changed massively over the last years. We are very lucky to have opened a new campus with brand new lab facilities that allow us to go with that change. And that new campus is in the Olympic Park. So if you remember the 2012 Olympic Games, the nice stadiums and nice facilities there, that is where a new campus was built, and the Department of Chemical Engineering is based in both campuses. Just to show you a few pictures, so this is where I work, this is where I teach, this is the new campus, and what you see here in the middle, it's the Marshgate building, and on the top floors, there you find the Manufacturing Futures Labs. Just a few images to show, these are not animations, so this building was opened last September all in place. And if you study with us in the new campus, you are welcomed by amazing lecture facilities, and of course, matched also by amazing lab facilities, very much designed for teaching, because you can imagine we have our research labs there as well, but they are labs and lab facilities very much designed for teaching. Without explaining too much about the big part of the new campus, the Manufacturing Futures Labs, which is also the host of the MSc program I'm going to describe now, I would like you to have a look at a few links. We have a very recent YouTube video explaining a bit how we teach there, and of course the website of the Manufacturing Futures Labs. But just to give you an idea, it's a very nice conglomerate hosted by 4 different departments where we teach you a lot on robotics, where we have on nanofabrication, material characterization, flow chemistry, high throughput, material science, microreactors, and all these things we need to combine the things of experimental research and computational research, as you will see in the next slides, is the key to the future of engineering and very much to sustainability as well. So let me dig into the MSc program I'm going to describe to you today, the digital manufacturing of advanced materials. So, well, what is digital manufacturing and what are advanced materials and why they're important for sustainability? Let me tackle these 2 questions separately. So, not sure if you know what digital manufacturing is, or a bit related to this term, Industry 4.0, the 4th Industrial Revolution. Well, we certainly don't remember the last ones, but you might know it from your history books. So, Industrial Revolution is what we call something if new technology changes the way we do things. You know, remember the first Industrial Revolution from your history books, end of 17th century, the steam engine, new ways of transport, changed the way the world was working. A bit later, beginning of the 19th century, electricity, telegraph, all these ways we could communicate. We had electricity in our sites, in our homes. That changed the world. And the 3rd Industrial Revolution, not that long ago, is the age of computers, and also the age where robots start to enter our manufacturing lines. And now is the question, well, what is Industrial 4.0, the 4th Industrial Revolution? And we think, although it's the times getting shorter, as you can see, there is already a change happening. And that is very much the combination of computers, very much AI and machine learning in combination with high throughput laboratories, with robotic systems that get smarter and smarter. So there are smart technologies and digitalization that are radically changing the way new chemicals and materials are developed. So this is what we call this hybrid of computers with advanced robotics and experimentational tools is the heart of digital manufacturing. And if you want to know why this is sustainable, well, that's very clear, because we can develop processes and products on a computer. We can, and if we do this, we can optimize them. And optimization is absolutely key to be sustainable. We need to reduce our carbon footprint. So we need absolutely optimized processes, and we can optimize for, of course, low consumables, of yield, and very much minimize the carbon footprint. And of course, once we fully understand things, we can also make them much more efficient, and we can reduce the dimensions and the energy needed to produce goods. And that is very much at the heart of the sustainability endeavor we are facing in this world. So let me explain what advanced materials are. Well, that might be a bit more intuitive and maybe something more clear to you. So all the demands we have to face the global challenges, we have a new demands for energy generation and storage. Just to give you some examples, we need affordable solar cells, we need long-lasting solar cells, we need hydrogen storage for fuel cell-driven mobility, we need a much more efficient materials for healthcare and medicine, and that is, for example, my research areas. I'm very much into nanomaterials for healthcare and medicine, and very much new ways to develop 100% or maximum sustainable processes that produce our goods with a minimum amount of efforts and resources needed. And that, again, is where chemical engineers are much in demand. And this is the second bit where this MSc program focuses on. Yeah, we need to develop and produce advanced materials to tackle these challenges. And now, what are we teaching? Well, we can learn from computers. Humans have achieved a lot, but now, as you can see, I think you know the examples much better, how quickly AI and other things are changing the way we're doing things, and it's incredibly powerful, and it became powerful over the last 5 years, not because the mathematics or algorithms are better. It's very much the available data now that empowers these technologies. And just to give you some very rough example how this could work for material discovery, well, go back, you might still remember in high school, if you have some data, let me give you the example of some materials, and we want to discuss viscosity and temperature. We might do some experiments. We might have a linear correlation. For every linear correlation, and you might find this with viscosity and temperature, 2 parameters are enough, and you can have a reasonable model. And once you have a model, you have a mathematical approach, and you can optimize on computers, etc. This is not the case when things getting much more complex. As you can see here, you don't have to understand this, but that's a simplified version of an artificial neural network. So very much the heart of many of these machine learning and AI tools you're using already. Again, very simplified. But as you can see, and every dot here represents a parameter. So for every dot, we need to calibrate and get the value of this parameter for these approaches to make sense. And as you can imagine now from the slide I showed before and what I show you now, in order to comprehend and understand how these parameters affect the materials in the end, we need to do hundreds, thousands, and millions of experiments and ask a friend who's working in a laboratory. This is obviously not possible, but that is now where the digital manufacturing comes into place. This is now where labs have changed massively. We have a lot more robotics, we have a lot more automation, autonomous systems in the lab that produce, that develop, that manufacture for us. So this is very much a new skill set that we need to prepare the future engineers. And this is the heart of our program, the digital manufacturing of advanced materials. We teach things like robotics, the lab skills for these advanced things, but also the computational skills. We start to teach coding for beginners, yeah, just to highlight this, for beginners, but we very much try to bridge this, to have graduates with computational skills, but also lab skills in these demanding environments that are new. And we are very privileged to have also the laboratory facilities to do that. It's a 1-year program, where in term 1, we start with the basics. We move in term 2 to things like automation. We go in the lab, and term 3 is the MSc research project. Just some highlights from the current cohort. So we're running this program for the very first time this year. As the building is new, the facilities are new, and very much the program as well. So we have completely new modules, brand new lab facilities, as you can see here. So we also have hands-on experience, not only with things like nanomaterial synthesis, but very much also electronics, sensor integration. And again, we start from the very basics, yeah? The idea is not to make you experts in one of this. The idea is to get expertise from whatever background you have that's science or engineering related, to get you up to speed on this multidisciplinary field. We have teaching of robotics combined with programming and material synthesis. So what you see here are the students, our very first cohort, how they use robots to synthesize nanomaterials, how they do XRD analysis, and how they start becoming very familiar with these robotic lab environments. We have a very strong impact from industry as well. So just in the first term, so there are 3 terms, just in the first term, we had many industrial guest lectures. We actually have industry talking about their need in these skills and giving us examples on how robotics, automation, and computational tools come together. So we are very privileged to have had a lot of very interesting industrial talks, which also gives the students a way to engage with our industrial partners. Lucy might have mentioned UCL has a fantastic careers team. But what I always say, if you're really interested what to study, and I assume that's where you are now, have a look at the job market right now. Have a look at jobs that are out now. If they would interest you in what are the skills that I need. I said for this MSc, it's for skills for industry and academia alike. So I went on a job site, and you can very much see skills that are combining laboratory and computational skills are in demand in industry, as well as for academic careers. If you would like to do a PhD afterwards, this is again from the chemical engineering side. You find a lot of information and a lot of skills very much that we teach in this MSc program are needed to start a PhD afterwards. Who is this program for? I'll keep this short. It's in the material Lucy shared as well. As I've said, it's for all engineers and scientists in allied fields. All of them are welcome. We start all these disciplines I mentioned from the beginning. If you want to learn more, stay in touch. There's a program video I would also like to bring to your attention a very nice lecture where we speak 1 hour, a bit more of this hybrid of modeling and experimentation. And if you have any questions, I'm looking forward to the Q&A session afterwards. You can always reach out to me directly via email. My email address is here. The application for this program, the link is here as well. And again, very recently we published the video for our virtual open day. The link is provided here as well. So thank you very much for my attention. And this is where I hand over now to my colleague, Dr. Catherine Cashel.
And hello, everybody. It's lovely to be here today. My name is Catherine Cashel. As Lucy already introduced me, I'm an associate professor in structural engineering and design in the Department of Civil, Environmental and Geomatic Engineering at UCL. I was listening to Max and Lucy earlier talking about the age of their departments and faculties, and I think civil engineering can win because we are nearly 200 years old. So we have been established since 1827, one of the very oldest and most established civil engineering departments in the world. Of course, we've moved on and changed an awful lot since we were first set up. And nowadays, sustainability in particular underpins everything we do. So absolutely all of our programs, all of our modules, our teaching, our research, and daily life within the department is very much governed by sustainability, and in particular, the climate emergency through which we are currently living. We're a very broad department. We still cover many of the traditional civil engineering topics. So we have ground engineering, structural engineering, transportation engineering, and so on. But we also have a lot of more, I was going to say modern, but maybe newer topics within the broad sphere of civil engineering. So things like geomatics, robotics, environmental engineering, human-centered engineering, and so on. We have some of the world-leading experts in these areas in our department, so our students are learning from the very best and engaging with the very best. Today, I'm going to talk specifically about how we tackle sustainability and the environment, climate change, and so on within our department. And as I said, it's fair to say that this underpins absolutely everything that we do. Here on this slide, I won't go into too much detail, but for those of you that are not familiar with civil engineering and the built environment in particular detail, we have a huge part to play in global carbon emissions. So we are one of the biggest emitters of carbon emissions. I say that as the we is the built environment. So roughly responsible for about 20% of carbon emissions globally. So that really means that we have the power to make a real difference. Anything we do as a sector, no matter how small, has the power to have an awful lot of influence. So that's quite an exciting prospect for those of us who are working in civil engineering. So briefly, this slide just shows how connected we are. So obviously UCL is a hugely well-known and well-established university, a top 10 university in the world. And as such, we attract students from all over the world. So we are very much a global department and university. We have students, graduates, staff, and so on from over 190 countries in the world. And our network is extremely wide, and we daily engage with people from all over the world. On the other hand, our very central location in London places us next to some of the largest engineering firms in the world. So as I click through these, they're appearing, and you can see UCL is in the center of our screen. And many of the largest engineering firms from around the world are on our doorstep. And we work with them all the time in both our teaching and our research. So we have projects which are given to us by our industrial partners and our students work on. And of course, from a careers perspective, it's very important. So our students have access and direct access to some of the largest engineering companies in the world. Also on here, we have the Institution of Structural Engineers, the Institution of Civil Engineers is closer to Westminster, that should pop up shortly. And we have very strong links with these professional organizations also. There's the ICE has just popped up. Again, in terms of where our graduates work, I've just popped up a few different names. on the screen here, but of course, this is just a small snapshot. Our graduates are working all over the world with many different companies. So very briefly, and I'm conscious that not everyone on the call is necessarily interested in civil engineering or knows very much about civil engineering, but I'm going to just give you a very brief overview of what the subject is in the current climate. So it's a very, very broad-ranging engineering discipline. We work with stakeholders, we work with clients, we work with people who have lots of money and want to build big buildings, small buildings, bridges, and so on. Civil engineers, after working and while working with stakeholders, we also consider the benefits and costs, and we design and build whatever it is that we are being tasked to do. Then we manage and improve that piece of civil engineering infrastructure. And then very importantly, we manage the cleanup, or what happens at the end of life for that structure or civil engineering application. And in every single one of these stages of a project, sustainability is very much at the forefront of all activities that are undertaken. And I should say as well at this point that when we talk about sustainability in a civil engineering context, traditionally it's mainly been about carbon. So I've mentioned carbon already. So that's obviously a big part of it. So environmental sustainability. But increasingly, we are also starting to work an awful lot with social sustainability, biodiversity, and of course, economic sustainability is never too far away either. So very briefly, we have a lot of MSc programs, so master's programs. We have a huge number just within our department in a very, very broad variety of topics. So here I've just put a whole load of them up on the screen, but we have the MSc in civil engineering, which is hugely popular, and it's different strands depending on your interests. So looking at the environment, fluids, infrastructure, and so on. We have a real strength in our department, as I will describe later, in earthquake engineering, seismic engineering, ground engineering. So we have MScs in many of these subjects. Also, geospatial is another key topic, and particularly looking at building information modeling, looking at also the use of robotics and AI in monitoring buildings. At the bottom of that list, you will see that we have a new MSc, which will be coming in 2025, of which I will be the program director, in sustainable structural engineering. So we're very, very excited about the launch of this program. The timing seems to be particularly good in the sense that we are one of the very few universities that is starting a new program entirely with sustainability in mind. So although we will still be covering many of the traditional structural engineering topics, and it will be, of course, a very technical course, sustainability will be absolutely embedded in everything that we do. So every module will cover some aspect of sustainability. And that brings me around to a little bit more detail on some of the work and the research work, particularly that we do in our department. So much of what we do in structural engineering in particular, which is my own area, both in teaching and in research and development, is about trying to find a balance between sustainability, so particularly environmental sustainability, and resilience. And this is a very, very challenging dilemma, I guess, going forward. So this slide somehow shows that real challenge for those of us that are working in buildings and infrastructure. How do we make our structures be more resilient? So we want them to be able to withstand things that they've never had to withstand before. So extreme temperatures, flooding, fires, earthquakes, all sorts of natural and man-made disasters. But at the same time, we're also trying to design our buildings and structures to be more sustainable. And the traditional way of making a structure more resilient is to make it stronger by using more materials and making everything a little bit bigger and stockier. And of course, that's not particularly sustainable because it involves using a lot more materials. So what we are focusing on here at UCL and in my department is really trying to develop a very deep and detailed technical understanding of where we need to use our materials and our products and our energy so that it gets the most bang for its buck, so that we get the most out of it and make it really earn its place and earn that use of carbon. So this is just a slide that I took from a recent presentation I gave specifically about net zero. So trying to build, and bearing in mind that my own area of interest is buildings and bridges. So trying to build new or rehabilitate existing structures, mainly just by using less stuff. So using less material and less energy. And then when we do need to use material, we try to specify low carbon or even offset the carbon emissions. So option number one, and we explore this a lot with our students, particularly now starting to look at some of the ethical considerations, is actually the option to build nothing. So can we, and can our students work with existing building stock, adapt existing building stock to meet the needs of tomorrow? And then it's building less, building clever, and building efficiently. So we go through these steps with all of our projects. And really the idea is just to try to use less stuff, and that we do use, make it work a little bit harder. Another thing that you may have seen in the news recently is this bridge collapse. This bridge collapsed in Baltimore in the US a couple of weeks ago. And we have, as I said before, we have world-leading experts in many aspects of civil engineering and structural engineering in particular in this case. And our experts were featured in many of the international media commenting about this particular episode. And we are also working with some bridge designers in trying to come up with mitigation, if possible, for events such as this, and balancing that mitigation, of course, with the sustainability challenge. Similarly, I mentioned earlier that we have a real expertise in our department in earthquake engineering and seismology. And this, there was an earthquake last week, some of you may be aware, in Taiwan. And again, some professors from our department were featured. This is a news article from the Times newspaper in the UK, commenting on actually how previous research that we conducted here in our department in collaboration with engineers in Taiwan were implemented following a major earthquake in 1999. That earthquake killed 2,415 people, and the one last week killed far, far less. I believe it was 10 or fewer people died in last week's earthquake. So obviously that's extremely a very tragic and costly event, but thankfully some of the measures that were taken into account for earthquakes from our professors were able to prevent it becoming an even larger humanitarian disaster. Finally, and this is going to be my last slide, this is just some of the work that some of our MSc students do here. We are very, very keen on practical and lab-based work. So we don't just learn about this here as it happens to be a concrete beam. We don't just learn about the behavior. We get into the lab with our students. We get them to build and break things so that they truly understand how they behave. And that's it from me. So I am going to hand back to Lucy, and I welcome any questions at the end. Thank you very much.
Thanks, Max and Catherine. Great to hear a bit more about the offering in your particular department and what specialist MSc programs are available for those with an interest in sustainable engineering. It's particularly great to see those examples of what's going on over at the UCL East campus and those brilliant new lab facilities as well. I'm going to just run through our last few slides with you today, and then I'll pass over to Gareth, who's agreed to share Q&A for us. So here you go, just a little note I mentioned earlier about the scholarships and bursaries. Just like to point out that there are a number of scholarships still open for this year. The link and QR code here will take you to our website where you can find out more about funding options and the Global Master Scholarship and East London Scholarship for UCL East and Canary Wharf based programs still open at present. It's also well worth following us on any social media you use. We share and celebrate news from the faculty and the departments, including study opportunities, research stories and information about student life at UCL and in London on those. I've also added the email address for our student recruitment inbox if you have any questions about an MSc in particular. I've seen there's one of those in the Q&A at the moment, or about UCL engineering more broadly. Please do feel free to email us, and one of my team will respond to you in due course. I then also just wanted to finish by inviting you to the UCL Festival of Engineering this summer. 2024 is a big year for us as it represents, broadly speaking, our 150th anniversary. Across 6 days, we're going to be engaging with audiences across London and internationally to show how UCL engineers are addressing the most urgent challenges for people and the planet. Activities include a launch event at the Palace of Westminster, trade show for employers and industry, lab tours, careers events for schools and community groups, and an augmented reality tour of UCL campus. Best of all, it's free and open to all of you, friends, family. It will be live streamed. Some of the events will be live streamed for those of you joining us internationally, and everything else will be in person for those of you able to make it to London that week. So please do join us. As you can see, the themes that we've selected, climate crisis and fair world, are obviously resonate highly with sustainable engineering. So I'll pass over to Gareth now, who I think is going to chair our Q&A.
Excellent, thank you, Lucy, Max, and Catherine. Thank you for your time. Really appreciate that. It's been a great session because engineering is the focal point of everything that goes on, well, in people's careers and life, I suppose. So I do have a few questions that have come in on social media, a few questions that I suppose I'm interested in as well. Catherine, I want to begin with you. I thought the slide where you brought up where your graduates currently work was really interesting because, like I mentioned, it's so key to society and careers and life as a whole, engineering. And it's so important to point out that it's not just engineering roles that people go into. It's all different types of roles. So how important is that, especially being London based, where, you know, central London pretty much as well? I know you're a little bit on the north side, but you know, it's very, very local to anyone living in London. Logistically very simple. But how important is it that students have got that accessibility to key employers around the world?
Great, thanks, Gareth. Yeah, it's hugely important, I would say. We have 100% employability, so our graduates all go into work of their choosing. I will say that they don't all become civil engineers. So although they come and they study in our department, we have many that go to work for charities, that go to work for banks, that go to work for government agencies, all over. I mean, it's actually kind of mind-boggling, the variety of employment opportunities that are available to students, particularly these days. I feel like that's increasing. So having access, so not just access to these companies on our doorstep, but we have many of these companies coming into our department. So they're coming in, they're teaching not just engineering firms, and actually there's a queue of them who want to come in because they want access to our graduates. So we're able to be quite picky and just get the best, or the ones that we think will bring the best opportunities.
Okay, and that would kind of follow on nicely as well. A question for me is, what are you looking for within a student? Are you looking at them from an academic viewpoint? Are you looking at from a personality viewpoint? What would you recommend to students if they're looking at their personal statement and they're looking to come and study with you guys at a master's level? What are you looking for in particular?
So I think it depends from program to program. So we'll have many programs that will require certain technical skills or a certain background or whatever. But we actually have a whole load of programs with very broad entry criteria. And it's quite a hard question to ask, but I think if pushed, then I would say what we're often looking for is just interest, like actual genuine interest in the subject. So someone who is inquisitive and who really wants to come and learn. And we try to decipher that from the personal statement, just how motivated they are for the subject above all else.
And Max, would you emphasize that also, obviously, given that, you know, you do kind of chemical engineering and those related courses, quite often students don't know what niche area they want to go into, and therefore, broadly speaking, they go in with their eyes wide open.
That's the right approach. Just to clarify again, especially these new MSc programs, we're not talking about undergraduate, we're talking here about postgraduate programs. So they are by nature interdisciplinary. So I showed that slide, it was a bit quick. So we are looking for engineers and scientists, so pretty much everyone with a technical or technical related background. And what we're looking for in a student is not expertise in programming, not expertise in materials, not expertise in robotics, because these are the things we teach, yeah? We want students who are interested in these things. So that's maybe I would like to really strengthen this out. We do not expect students and applicants to have this knowledge, because if they would have knowledge, they should not study these things. So we are looking for motivated students. So if you are applying and the application letter and these things, that should get across like you are motivated to do these things. Because if you say, look, I cannot code, I don't want to learn coding, that's then a problem, because it's absolutely okay if you cannot, but if you also do not want, if that's not your interest, that's nothing where we can do anything. But if you cannot, but you want to learn, then we can teach you.
Absolutely. And Lucy, talk to me about the different array of nationalities within the department, because no doubt UCL is a very international university. Does that stem through to the engineering department, and therefore do you see a huge amount of different cultures and everyone is kind of in the same boat when they arrive from their respective countries?
Yeah, completely. I think UCL is a truly global institution, and the engineering faculty is, again, uniquely international. Our staff and students join us, I think, at present from over 120 nations across Europe, the Americas, Africa, China, India, Middle East, Far East, Australasia, as do our academics and business partners and industry connections. I would say that too. It's really wonderful to see the diversity of thought in the classroom. I think it makes for a really interesting learning experience as well as a social experience. And yes, I would say that we're very aware that it is, for some people, they will land and go straight into their into the UCL community the next day without any real connections or close friends or family near to them. We run a very comprehensive welcome program. UCL Central has its kind of standard Freshers Week, but for MSc and for PhD students in UCL Engineering particularly, we run a series of welcome events to ensure that everybody hits the ground running and has the opportunity to connect with that kind of global community as they join.
And also as well, we saw in Max's presentation, and Lucy, I'm going to stay with you here, but we saw in Max's presentation about the great images about where the campus is. You know, you got the 2012 Olympics that were held by the Olympic Stadium and whatnot. People might look at that, in particular international students who can get anxious about moving and worried about the cost of living. It's important to note that it is so easy to get to all across London with the infrastructure that's in place. No doubt there'll be people that live on the outskirts and can travel in within 20 minutes and don't have to live in central London.
I think I can speak for most of the staff at UCL that it's not common for us all to live in central London. I can imagine that for international and for home students, part of the draw of UCL is coming and living in the centre and experiencing what central London is and feels like. But what I would say is that it's very easy. The train and tube network, the bus network connections in across and out towards the outskirts of London is really quite exceptional. I think my family, for example, lives 60 miles from London, and it takes 48 minutes to get in on the train. And that's going somewhere which is far more affordable to live than the middle of London. What we would say is that do take a look at the comprehensive kind of bursary and scholarship packages available as well. I think the London experience is really important for those who come to UCL. I'd also say that our new sort of dual campus structure is a really fantastic opportunity to see what central London has to offer and to be part of a really kind of thriving new community over at UCL Stratford, with its kind of history in the Queen Elizabeth Olympic Park. It's also a brand new sort of culture arena is springing up in that area. There's lots of theatres, media companies, that sort of thing, moving out to East on the understanding that it's a fantastic new community to be part of and get set up in.
Excellent. And Catherine, just coming to you again, I want to talk about one of the big things that I got from your section was sustainability, and that's probably one of the biggest changes in the last 20-25 years within the engineering department, in the globe, really. That's so important. How important is that to your department in particular civil engineering, that sustainability is at the forefront of everything that you guys do moving forward?
Yeah, it's colossally important. It's almost become taken for granted. We don't even really talk about it all that much anymore. It's completely embedded. So from a just accreditation, all our programs are accredited by the professional institutions. as meeting the requirements for chartered engineer status. And for that, you have to have sustainability. So even if we didn't want to, it's there. However, we would be one of the institutions that actually took a lead in this. I don't know, maybe 30 years ago, before my time anyway. And it's completely embedded, as I say. So we don't even include it in titles of things much anymore. Now, I know in the new program we are including it, because actually structural engineering, which is my own area, is one of the last to catch up. It's one of the ones that, I mean that as a sector rather than a university. We are one of the biggest culprits, if you like, for carbon emissions. So we have the furthest to go, I guess. So we actually thought, we had a lot of discussion, and we thought if we probably need to make it quite obvious that anyone coming to do this program should expect to have a sustainability based approach.
Yeah, of course. Max, kind of the same for your department as well. Like Catherine mentioned, it's kind of embedded now within everyone, but it kind of, you can't evade the fact that it's so important these days.
You mean how sustainability is integrated?
Yeah, of course. Yeah.
As you say, it comes by nature, and let's be quite frank about it. The nature is not only political pressure, the nature is also cost of producing goods, because everything becomes more expensive. It's a problem of resources. So we're naturally driven to make things more efficient. We're naturally driven for process intensification. We're naturally driven to make things green, recyclable, efficient, and with a low CO2 footprint. So probably we're a bit late as a society to make this a priority, but it's now a priority for all the right reasons. And unfortunately, not all of them are pleasant. So it's a priority also because we have reached, I guess, a limit in certain fields.
Thank you. Lucy, I just want to finish up with one final point. One of the questions that was answered earlier, and I think is so important to talk about, is there was a student that's currently studying a mathematics degree at undergrad level. Can they go on and study master's level engineering? Of course they can. And how important is that to re-emphasize that just because their undergrad degree isn't in civil engineering or engineering as a whole, they can still very much be part of that kind of department moving forward?
Yeah, I mean, I think most of our programs have a minimum of a 2-1 bachelor's degree or equivalent sort of requirement in terms of prerequisites in a relevant subject area. Now, that means that's going to depend by program and by department, but mathematics, for example, it's seriously important in underpinning most engineering principles. I think we could say the same about some of the natural sciences will align really well to our programs in biomedical engineering. I would not see particularly at a master's level, that being a restriction. And I would say, if you have any concerns or questions about whether you think that your prerequisite sort of undergraduate degree is relevant, then please do get in touch with us. I'm going to leave my email address here as well.
Excellent. And just to finish up as well, just before I talk about the bursary opportunity that we offer here at Postgrad Solutions, opportunities for students to join you guys, the intakes, presumably the main ones in September. Do you offer January intakes? Are there, multiple intakes per year? What do you guys look at, and when's the main time to join?
So there's an opportunity for postgraduate research students to join us for a variety of times of the year. But for postgraduate tour programs, September is really our entry. We have sort of very rigorous 1-year programs, which involve sort of module teaching in first term, second term, and then your kind of individual research projects in the third term over the summer. What I would say is that for those of you who are considering applying for 2024 entry, it's still not too late. As I said, for anyone requiring a visa, you have until the 28th of June to make an application. For UK. It's the 31st of August, just because we account for visa processing times within those application deadlines. And then for those considering next year, look out for our programs reopening in the middle of October with a similar kind of framework for next year's cycle.
Absolutely.
And best of luck.
It's important to have that open book, because so many universities and departments now close themselves off, and students may just have a hunch that they want to join there and then on a research level or on a face-to-face level. So I think that's so important. Just before we do wrap up, just a reminder, anyone that's watching today, there is the opportunity to apply for a £2,000 bursary, courtesy of Postgrad Solutions. Anyone from around the world, anyone studying any course within the UK or non-UK can apply. Head over to postgrad.com for your chance to apply. But for now, a huge thank you to all those involved, Lucy, Max and Catherine. It's been a great session. Really loved catching up with you guys. Hopefully we can do this again over the next couple of years. If anyone has any questions, look on the screen, Gareth at postgradsolutions.com. Everybody that is watching or is registered will be sent a live link to watch this moving forward. But for now, a huge thank you. I look forward to seeing you again soon. Thank you. Bye-bye.